Welcome back. This is the third and final lesson of week 15. In this lesson, we'll look at two further registers, the program counter and the accumulator. In this lesson, we'll look at the names of the 5 key registers. We'll see the job of the program counter and how it's used in sequence, selection and iteration structures. And then we'll look at the job of the accumulator and how all 5 registers work together in the fetch execute cycle. There are 5 key registers inside the processor. We've already looked at 3 of these, the MAR, the MDR and the CIR. You should have notes on these 3 registers. In this lesson, we'll look at 2 further key registers, the program counter and the accumulator. We'll learn what their jobs are in the fetch execute cycle. The job of the program counter is to tell the processor where to go for the next instruction in the program. When you start a new piece of software, running a piece of software or a program you've written, the program counter is set to the first line of that program, the first instruction. It sends the address of that instruction to the MAR. It then increments by 1. It counts on 1 to the next instruction, ready for the next cycle of the fetch execute cycle. And in this way, it counts 1 by 1 through the instructions in the program, starting at the beginning and going through them in order. So let's look at this in action. When you start to run a program, the program counter points to address 1, the first instruction in the program. It sends that instruction to the memory address register and then increments by 1. It's now ready for the next cycle and it waits until the next cycle begins. The MAR sends that address to RAM. The instruction from that address is fetched and sent back to the MDR. We've already seen what happens with the rest of the fetch execute cycle. The program counter is holding address 2 now, so it's ready to go on to the next instruction in the sequence. But of course, sequence isn't the only type of program structure. We've learnt that there are 2 other structures called selection and iteration. Selection is when you have an if statement and iteration is when you have a loop. These structures, these program structures, are implemented using a technique called branching. When a program has an iteration or selection instruction, it resets the number in the program counter. An if statement can cause the program counter to hop forward, jumping over some instructions, just like an if-else statement will. And a loop instruction will cause the program counter to hop backwards and repeat some instructions. So let's look at branching in action. In this example, the program counter is pointing to address 1. It sends that address to the MAR and increments to address 2, ready for the next instruction cycle. The MAR sends address 1 to RAM and fetches the instruction that's there. Let's say the instruction says branch to instruction 9. This instruction will overwrite the program counter so that the program counter jumps to address 9. This is an example of branching. The next cycle of the fetch execute cycle will execute the instruction at address 9 instead of address 2. For example, if there's been an if statement. So pulling all that together, the program counter holds the address of the next instruction. It normally increments by 1, and that's called sequence. Sometimes it's overwritten by an instruction, and that's called branching. The second register that we're going to learn about this lesson is called the accumulator. The accumulator is inside the ALU and it stores the result of the current instruction. It can only store one number at a time. Many of the instructions which we execute during a program will directly affect the accumulator. If we load a number directly from storage, it will overwrite what's in the accumulator. If we input a value, for instance, type it in, that can overwrite the value in the accumulator. Or we can output whatever number is in the accumulator and print it out, for instance, on the screen. There are other instructions that allow us to add one value to the accumulator, making it larger. And finally, an instruction will store the number that's in the accumulator back to RAM. We'll learn more about this next week. I'm just going to summarise in one place everything that I've said about how the different registers operate together during the instruction cycle. At the start of the instruction cycle, we're in the fetch phase of the fetch execute cycle. The PC, the program counter, holds the address of the next instruction. It sends that address to the MAR and increments by 1. Whatever is at that address is fetched from RAM and stored in the MDR. The instruction part of it is split off and put in the CIR. That's the end of the fetch part of the fetch execute cycle. We're now in the decode part of the cycle. The instruction code in the CIR is sent to the control unit, which decodes it to create a control signal. That control signal is now executed, so we're at the execute phase of the fetch execute cycle. At the execute phase, the instruction code controls the operation of some part of the computer, let's say the ALU. The data to be used in the operation is fetched from the MDR. And the result of the operation is stored in the accumulator. So the operation has now been executed. We're now in the final store phase of the fetch execute cycle. The result in the accumulator is sent to the MDR, ready to be stored, and the address where the data has to be stored in RAM is in the MAR. All of this is sent to RAM and the instruction cycle is complete. You don't necessarily have to remember every part of this detail, but I think it's a good idea that you have a general idea what each of the 5 registers does and how they all work together. So to recap, in this lesson you've learned about 2 new registers. The program counter that counts through the instructions of a program, starting at 1 and just counting through one by one. And the accumulator, which is inside the ALU and stores the result of the latest instruction. You should understand the difference between ordinary sequencing in programs where the PC just counts through 1, 2, 3, 4 through the different instructions, and a special kind of instruction called branching, which overwrites the program counter, and this is used when we've got an if structure or a loop structure in our programs. And you should have at least some idea of how all the different registers that we've learned about work together to make the fetch execute cycle inside the processor. There's a worksheet for my students. If you're not my student, you can just make notes on these things, and you'll need to write what you know about all 5 different registers. You should know the initials, what the initials stand for, and at least 1 sentence or 2 about what each of these registers do during the fetch execute cycle. Okay, so this is the end of week 15. It's been quite a technical week where we've looked in detail at things going on inside the processor. Next week, we'll start to write assembly language programs which work with these registers, and we can program them directly. Okay, bye for now.